Hey guys, welcome back. Today we are diving into some 8th grade math. It's not too bad though. Dilations. So, a dilation is when you're enlarging or you're reducing the size of a shape. And for this lesson, we are going to look at how that happens on a graph. So, there is a lot to dilations. We're just going to kind of dip our toes into it. Um, the amount that you have to know is like this, but there's a lot more to it that you're going to learn later. So a similar this is basically similar figures on a graph. Similar figures on a graph. So we're going to be looking at coordinates and you'll see. So usually we talk about art. Anybody in art? Yes, no, I'm going to pretend. There's some of you going, yeah, me. If you've ever heard about a vanishing point, dilations and vanishing points kind of go a little bit hand in hand. The center of dilation is our vanishing point. And for those of you who aren't in art, vanishing point. If you've ever looked at a painting and like the street is kind of doing this as it goes down, and like there's this point where like everything kind of points to this one spot in the middle. Sometimes it might be off to the side, sometimes it's right smack in the middle, and everything kind of angles towards that point. That's a vanishing point. All right, so we are going to start with a grid. We're only going to do quadrant 1. They can be all over the place, but for today, we're just going to focus on quadrant 1. And I'm going to draw triangle ABC. ABC. It does not have to be a right triangle. A, B, C. Sure. Okay. We're going to put this on a graph. It's got lines, it's got dots. There's another triangle that got bigger. It was enlarged in size. It's further out on the graph, and it looks like, I'm always bad at this. Here we go. The way you do this, we're going to use the origin as the vanishing point, and you draw a line from the vanishing point through the vertice and out. Through the vanishing point, out, and then through this point and out. And now it's a similar figure. It's going to hit on these 3 lines. I'm always very terrible at this. I hope that the warm-up you guys did today kind of helps. So it goes like this, and then like this. Ooh, I don't think my lines were straight, but it'll be okay. Like this, and then like this. Oh, I'm so bad at this. Sure. Oh, that's hideous. Oh, it's so bad. But you get the idea. Okay, so there's a bigger triangle. This is A, B, C. But so that we can tell the difference between this A and this A, the original A is just A. But the other A has a little 1 next to it, and the B has a little 1, and the C has a little 1, so that we can differentiate between, okay, this was the original A, and then this is new A. Original B, original C, new C. This is also how so this is the original, and the one with the little tick marks, or it's a 1. This is the new shape. So we've enlarged this on the graph. We used the origin as the center of dilation, but it does not have to be the origin for everything y'all need to know. That's all you need to know. Now we're looking at scale factor. The scale factor of a shape is how much you are enlarging it by or reducing it by. If the scale factor, this is just a rule, it's a rule that you should just know. The scale factor is how much it changes. The scale factor is kind of like when we did similar figures and things are being multiplied. It's multiplying or dividing. Or let's just go with multiplying. So not adding. Don't add. We're talking about proportions, so we're multiplying. If it got bigger, then the scale factor was greater than 1. So if it was an enlargement, the scale factor was more than 1. If it was a reduction, then it was less than 1. Okay, here's the math parts of this. If I had triangle A, B, C, and my coordinates were 8, 2 for A, 8, 6 for B, and 2, 4 for C, and my new coordinates for A sub 1, I think is how that's called, was 4, 1. What am I doing to my coordinates? How did I get from an 8 to a 4? It's half. From 8 to 4, it's halving. From 2 to 1, it's halving. Okay? So I'm multiplying by 1/2 or dividing by 2. So what about B? Keeping the same rule. What would X be for my new B? It would also be 4. What about the 6? What is my new Y? It would be 3 because half. Okay. What about new C? What would be the coordinates of new C? 1, 2. So my scale factor here, did my shape get bigger or smaller? It got smaller. So is my scale factor more than 1 or less than 1? It is less than 1. To be specific, how did you get from here to here again? We multiplied by 1/2. So my scale factor is 1/2. So what you do with your scale factor is you multiply each coordinate by the scale factor to get the new coordinate. This takes practice. You'll really get the hang of it. Revisit that Desmos activity. That was really great. I'll link it in the comments or something here, or I'll link it in the description. I will see you guys next time. Good luck. Let me know if you have any questions. Bye.